How can a structure built more than 4,500 years ago be aligned to true north with greater precision than most modern buildings? And how did ancient builders move and place stone blocks weighing up to 70 tons with millimetric accuracy, without steel machines, without engines, without digital measurement? These are not romantic questions. They are engineering contradictions. The Great Pyramid of Giza is often described as mysterious, symbolic, or sacred. But before it is any of those things, it is a problem. A problem of precision. A problem of logistics. A problem of mathematics that does not sit comfortably within its historical timeline. To understand this paradox, we must step into a quieter place. Not a museum. Not a textbook. A monument standing alone in the desert, where the night air cools the stone, and the shape of the pyramid slowly emerges from darkness, immense and silent, as it has for millennia. What makes the Great Pyramid unsettling is not its age. It is the uncomfortable possibility that its builders knew far more than we are prepared to expect. The Great Pyramid is not paradoxical because it is ancient. It is paradoxical because its level of precision exceeds what we expect from its era. Its measurements are not approximate. Its alignments are not symbolic. They are exact enough to make modern engineers pause. This film is not an argument for lost magic or forgotten technology beyond human reach. It is an examination of competence, of planning, of patience applied at a scale that challenges our assumptions about early civilization. Perhaps the most unsettling possibility is not that something is missing from history, but that something has been misunderstood. The Great Pyramid may not be a mystery of origins. It may be evidence of a form of intelligence we no longer recognize. And to see it clearly, we must slow down. The first engineering feat reveals itself quietly, without spectacle. The Great Pyramid is aligned to true north with an error of only a few arc minutes, so small that it is almost difficult to visualize. A deviation thinner than the width of a human fingernail stretched across the length of the structure. This is not alignment by estimation. It is not symbolic orientation toward the sky. It is mathematical precision. True north is not the same as magnetic north. It does not reveal itself to a compass. It must be calculated through careful observation of the sky, or through methods that require time, repetition, and an intimate understanding of natural cycles. Even today, with satellite positioning, laser levels, and digital instruments, achieving this degree of accuracy across such a large footprint is not trivial. Small errors compound. Minor miscalculations become permanent. And yet, here it stands. Each side of the pyramid faces a cardinal direction with remarkable consistency. North, south, east, and west are not approximations. They are commitments. The paradox is not that ancient people looked at the stars. Many cultures did. The paradox is that the result rivals and often exceeds the precision of modern construction. No surviving records describe the exact method used. No diagrams explain the process. Only the outcome remains. An alignment so exact that it forces a quiet question. Not how inspired the builders were, but how disciplined. Beneath the visible precision of the pyramid lies a quieter achievement. The base on which the Great Pyramid stands is level to within mere centimeters across an area covering more than 13 acres. A foundation so flat that even today it challenges conventional expectations. This was not a small platform. It was a vast plain of stone, prepared to receive millions of tons of material. Any unevenness would have multiplied upward, magnifying errors with every rising layer. Leveling a surface of this size is difficult, even with modern surveying equipment. It requires reference points, consistent measurements, and the ability to correct deviations before they become permanent. The ancient builders had no aerial view, no satellite imagery, no laser-guided instruments. They could not step back far enough to see the whole. And yet the ground beneath the pyramid behaves as if it were measured from above. The methods remain uncertain. Some propose water-filled trenches. Others suggest repeated manual leveling and correction. None offer complete certainty. What remains undeniable is the result. A foundation prepared with patience rather than speed, with repetition rather than force, with an attention to consistency that borders on the obsessive. The paradox deepens here, not because the task is unimaginable, but because it demands something we rarely associate with the ancient world: sustained precision. The third engineering feat is often imagined as a problem of raw strength, of muscle overpowering stone, of sheer force applied again and again. But strength alone does not explain what happened here. The Great Pyramid is constructed from more than 2 million individual stone blocks. Most weigh between 2 and 5 tons. Some, particularly the granite blocks used in internal chambers, weigh as much as 70 tons. Each of these stones had to be quarried, shaped, transported, positioned, and placed with intention. Not once, but millions of times. Granite blocks were brought from Aswan, a distance of more than 800 kilometers along the Nile. Limestone casing stones were extracted locally, but finished with a precision that allowed them to fit together with gaps thinner than a human finger. This movement did not happen quickly. It unfolded over decades. There is no clear evidence of wheeled vehicles suitable for this task. No iron cranes. No complex pulley systems preserved in the archaeological record. What remains are simpler tools: wood, rope, stone, and human bodies working in coordination. We can imagine sledges sliding across prepared ground, sand dampened with water to reduce friction, teams moving in rhythm, guided not by speed, but by repetition. This is where the feat becomes less about power and more about control. Moving a heavy object once is impressive. Moving millions of them, without losing alignment, without collapsing the structure beneath, requires something else entirely. It requires planning that extends far beyond the present moment. Each block must arrive when it is needed, not too early, not too late. Each must be oriented correctly before it is set down, because correction afterward is costly, if not impossible. At this scale, error is not isolated. A single misplacement alters the course of the layer above it. A cumulative deviation becomes structural weakness. And yet the pyramid maintains consistency from its base to its upper courses. This suggests a construction process governed by systems rather than improvisation, by sequence rather than reaction. We often imagine ancient labor as chaotic, as loud, as driven by command and force. But the pyramid implies something quieter: a cadence. The same movements repeated day after day, the same distances measured with practiced steps, the same angles checked and rechecked by eye and hand. Human labor here does not appear exhausted. It appears disciplined. The stones do not feel rushed into place. They feel invited, each block resting exactly where it belongs, contributing its weight to the stability of everything around it. This was not the work of individuals acting independently. It was collective motion sustained over generations, a form of engineering that lived in the body rather than on paper, in memory rather than in manuals. Before mathematics was formalized, it was practiced. Before logistics were written down, they were embodied. The pyramid rose not because humans were stronger than we imagine, but because they were more coordinated than we often allow. And coordination, when sustained long enough, becomes indistinguishable from precision. The true paradox of this feat is not the weight of the stones. It is the system required to move them again and again without collapse. Strength can lift a block once, but only organization can lift millions of them in sequence over decades. To build the Great Pyramid, labor had to be coordinated across vast distances and long spans of time. Quarries hundreds of kilometers away had to operate in harmony with the construction site itself. Transport routes along the Nile had to remain reliable through seasonal flooding and drought. Staging areas had to receive, sort, and release stone at exactly the right pace. This kind of coordination does not emerge spontaneously. It must be designed, maintained, and protected from disruption. Food had to be produced and delivered consistently to sustain a large workforce. Shelter had to be organized. Tools had to be repaired or replaced before failure slowed the process. Every delay had consequences. Every disruption rippled outward. If stone arrived too early, it crowded the site and created disorder. If it arrived too late, workers stood idle and momentum was lost. If blocks were placed out of sequence, correction became exponentially more difficult as weight accumulated above. The pyramid demanded timing. This implies an understanding of workflow that feels strikingly modern. A sense of dependency, where one task cannot begin until another has reached completion. A recognition that efficiency is not speed, but balance. The work could not surge forward impulsively. It had to remain steady. What is remarkable is not that such a system existed briefly. It is that it endured. The construction of the Great Pyramid likely spanned more than 20 years. During that time, leadership changed. Workers aged. Environmental conditions shifted. And yet the structure maintains coherence from its lowest courses to its highest surviving stones. This suggests that the knowledge required to build it did not reside in a single individual. It was distributed, embedded in routine, preserved through repetition rather than instruction. No written manuals were necessary if the process itself became memory. Each generation of workers inherited not only tasks, but timing. Not only techniques, but rhythm. The pyramid rose because the system that built it was resilient. It could absorb small errors without unraveling. It could continue even as individual components failed or were replaced. This is the quiet sophistication of logistics. It is not visible in the finished shape. It leaves no ornament, but it governs everything. When we stand before the Great Pyramid today, we often imagine effort frozen in stone. But what we are truly seeing is coordination made permanent. Millions of decisions aligned toward a single outcome. Millions of moments where precision was chosen over haste. The paradox is not that ancient people could move stone. It is that they could maintain order for so long, across so many variables, without the systems we rely on today. And as this realization settles, the pyramid begins to feel less like a triumph of force, and more like a triumph of sustained discipline. A reminder that engineering is not always loud. Sometimes it is simply patient. If this quiet exploration of ancient engineering resonates with you, you're welcome to stay with us by subscribing. The fourth engineering feat is hidden from view. It exists not on the exterior of the pyramid, but deep within its core, where stone surrounds stone and weight presses downward with relentless force. At the heart of the Great Pyramid lies the King's Chamber, a room constructed entirely of granite, one of the hardest stones available to the ancient builders. Granite that had to be transported from distant quarries and shaped with extreme care. Granite that resists fracture, but also resists correction. Above this chamber sits a series of 5 spaces, often called relieving chambers. They appear simple, almost unfinished, but their purpose is precise. The Great Pyramid weighs several million tons. That weight does not rest evenly. It seeks paths of least resistance. It presses downward, searching for weaknesses. The King's Chamber lies directly beneath the central mass of the structure. Without intervention, the pressure above would crush the chamber below. And yet, it does not. Instead, the weight is redirected, distributed outward, carried away from the chamber by a carefully layered system of stone. This solution reflects an understanding of load management that feels unexpectedly modern. The relieving chambers do not eliminate weight. They manage it. Large granite beams span the space above the chamber, creating horizontal layers that intercept downward force. Above them, angled limestone blocks form a primitive gabled roof, guiding pressure toward the sides of the pyramid rather than directly downward. This is not accidental architecture. It is a response to stress. What makes this feat remarkable is not only that it works, but that it works at all. The builders could not simulate load distribution. They could not model stress with equations. They could not test multiple versions and discard failures. Mistakes here would have been catastrophic. A collapsed chamber would not simply require repair. It would compromise the integrity of everything above it. And yet the king's chamber has endured for more than 4,000 years. The granite beams show signs of stress. Small fractures exist, but the system holds. This suggests that the builders understood not only how stone behaves under weight, but how structures fail. They anticipated pressure points. They prepared for compression. They allowed stone to move slightly without breaking. This level of foresight is unsettling. Structural engineering, as a formal discipline, would not be defined for thousands of years. And yet here, its principles appear not as theory, but as practice. The pyramid does not rely on ornament to express intelligence. It relies on restraint. Nothing in the relieving chambers is decorative. Nothing is excessive. Every stone has a function. Every void exists for a reason. This speaks to a design philosophy focused not on visibility, but on endurance. The builders were not concerned with how this space would look. They were concerned with whether it would survive. And it has. The paradox deepens when we consider that this knowledge may never have been written down. It may never have existed as abstraction. It may have lived entirely in experience, in observation of collapse and stability, in trial refined over generations, in techniques passed from hand to hand rather than from text to text. The pyramid becomes, in this sense, a silent archive, not of words, but of solutions. Solutions embedded in stone, waiting to be noticed. And as we move deeper into the structure, the realization begins to form. This was not a culture guessing its way forward. It was a culture that understood weight and respected it. Beyond the hidden chambers and unseen weight paths, there is another layer of precision that governs the Great Pyramid. It is not structural alone, it is geometric. From its base to its apex, the pyramid follows proportions with extraordinary consistency. Its angles do not wander. Its slopes do not drift. Each face rises at nearly the same inclination, forming a shape so stable that it resists distortion even after millennia of erosion. This is not an easy thing to achieve. At small scales, geometry forgives error. At monumental scales, it amplifies it. A deviation of a single degree at the base becomes a visible failure at the top. A minor inconsistency in angle multiplies across hundreds of feet of stone. And yet the Great Pyramid maintains coherence. Its faces converge cleanly. Its edges remain straight. Its form resolves into a single point with remarkable discipline. This implies a method of measurement that extended beyond the moment of construction. The builders were not merely stacking stone. They were preserving ratios. Slopes had to be checked continuously. Courses had to align not only with what lay below, but with an imagined apex far above, one that did not yet exist. This requires foresight. The pyramid was not built impulsively. Its final shape governed its earliest decisions. Whether the proportions were chosen deliberately or emerged from repeated practice is still debated, but the result is undeniable. Consistency at this scale is difficult even with modern tools. The geometry of the pyramid also reveals an economy of design. There is no excess curvature, no decorative deviation. Each face behaves like a plane, each edge like a line drawn through space. This simplicity is deceptive. It hides complexity behind restraint. The builders had to manage not only vertical rise, but horizontal alignment. They had to ensure that all sides advanced upward at the same rate, that no face outpaced the others. That symmetry was preserved without constant correction. This suggests a shared reference system, not written measurements, but agreed standards. Lengths understood by the body, Angles memorized through repetition? Geometry here may not have been theoretical. It may have been practical. Knowledge carried in hands, in steps, in sightlines drawn across the desert. The pyramid does not announce its mathematics. It embodies it. And perhaps this is why it feels so unsettling. We expect ancient structures to reveal struggle, to show adjustment, to display compromise. The Great Pyramid does not. Its geometry feels resolved, as if the builders knew where they were going long before the first stone was placed. This challenges a familiar narrative. We often imagine early civilizations advancing slowly, refining knowledge over time. But the pyramid suggests something different, a moment of clarity, a convergence of skill, coordination, and understanding held steady long enough to become permanent. Whether these proportions carried symbolic meaning is secondary. What matters is that they were executed, perfectly enough to endure. The paradox is not that geometry appears here. Many cultures understood shape. The paradox is that it appears so controlled, so sustained, so quietly confident. The pyramid does not experiment. It commits. And as we stand back from its form, allowing its edges to blur into the sky, we begin to sense the deeper implication. This was not a structure searching for balance. It was built by people who already understood it. The journey through the Great Pyramid often begins with questions. How was it built? How was it measured? How was such precision sustained? But as the structure reveals itself layer by layer, those questions begin to soften. The feats we have observed are not impossible. They do not violate the laws of physics. They do not require technologies beyond human reach. What they require is something quieter: time, attention, discipline. Perhaps the true paradox of the Great Pyramid is not found in stone or measurement. Perhaps it lies in our expectations. We often imagine human progress as a straight line, primitive beginnings rising steadily toward modern sophistication, crudeness replaced by refinement, guesswork replaced by calculation. But the pyramid resists that story. It suggests that intelligence does not always move forward, that it can gather, focus, and then disperse, that moments of extraordinary competence can exist without leaving written explanation behind. The builders of the Great Pyramid did not leave us their formulas. They left us their results. A structure aligned with the sky, leveled against the earth, balanced under unimaginable weight, shaped by geometry that holds its form even as centuries pass. This does not mean something mystical was lost. It may mean something practical was forgotten. Ways of working that relied on repetition rather than abstraction, on shared rhythm rather than written instruction, on patience as a tool as powerful as any instrument. As we stand at the end of this exploration, the pyramid no longer demands to be solved. It asks to be observed, to be allowed to exist without being reduced to mystery or dismissed as coincidence. Perhaps the builders understood something we struggle to accept: that complexity does not always require noise, that precision does not require speed, that endurance is often the result of restraint. Now the desert begins to cool. The wind moves softly across stone that has absorbed heat all day. Edges that once appeared sharp begin to soften in shadow. The pyramid stands unchanged. Stars emerge slowly above it. The same stars that once guided careful alignment. The same sky that watched the first stones laid in place. Silence returns to the plateau. No calculations remain. No diagrams. Only mass and form and stillness. You no longer need to hold the questions. They can remain where they are, unanswered, unresolved. The pyramid does not require resolution to endure. Neither do you. Let the measurements fade. Let the angles dissolve. Let the weight settle back into the earth. Breath slows. Attention loosens. Stone returns to shadow. Shadow returns to night. And as the desert sleeps, the pyramid keeps its quiet watch. Unexplained, unbothered, at rest. There is nothing more to solve tonight. The stone remains, the silence remains, and you are free to rest within it. Good night.